Welcome to my notes on the fundamental counting principle. Now, before we get into how the fundamental counting principle works, we are going to review how to use a tree diagram to determine possible outcomes. So the first example here says, what are all the possible outcomes when you flip 3 coins? Now, what are the possibilities on a coin? You have heads and you have tails. So what we're going to do here is write and go as close to the margin as you can here. We're going to do heads and tails. Okay, now the second coin has heads and tails on it. So we can draw a branch from each coin, showing that you can have heads or tails. Now, so we can have heads, 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 tails, tails, heads, and tails, tails. Now, the third coin, we need to have a branch coming off of each coin here. So we have heads, tails. We have heads, tails. We have heads, tails. And we have heads, tails. So since the possibilities of flipping a coin are heads or tails, we need to have a branch coming off of each coin. So here's our first coin, here's our second coin, and here's our third coin. Okay. Now, let's write out all the possibilities. So we have heads, heads, heads. We have heads, heads, tails. We have heads, tails, heads. And last, we have heads, tails, tails. Now looking at this part of the tree diagram, we have tails, heads, heads. We have tails, heads, tails. We have tails, tails, heads. And lastly, we have tails, tails, tails. Okay, so if we count up all our possible outcomes, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 outcomes. And how many outcomes include flipping at least 2 tails? So we have this one, we have this one, we have this one, and we have this one. Because remember, at least 2 means 2 or more. So we have 4 possible outcomes. Okay, let's move down to example number 2, where it says, how many possible outcomes are there from flipping a coin and rolling a number cube? So once again, we are going to make a tree diagram, and we're flipping a coin and rolling a number cube. So the possibilities on a coin are heads or tails. Now, when you roll the die, we have 6 possible choices. We have 1, 2, 3, 4, 5, and 6. And then when we when we get a tails, we can also get 1, 2, 3. Oops. 1, 2, 3, 4, 5, and 6. So let's write out our possible outcomes. We can have heads and roll a 1. We can have heads and roll a 2. Heads and a 3. heads and a 4, heads and a 5, and heads and a 6. And then we can also have tails 1, 2, 3, 4, 5, and 6. Okay, so the questions below here ask how many different ways can you roll an even number with a heads? So how many times can we get an even number with a heads? Let's look. We have 2, 4, and 6. So how many possibilities is that? That's correct, 3. Okay. How many combinations are possible that will flip a tails? So we have this group right here, which is 6. Now, how many combinations will roll at least a 4? Remember, that's 4 or greater. So we have this one, and this one, so that's 3. And then we also have these 3 down here, so 4, 5, and 6. So a total of 6 outcomes. And then how many combinations will roll a number less than 3 and flip a heads? So less than 3 is 2 and 1 and roll a heads. So it's these 2 right here. So we have 2 outcomes. Okay. Now turn to page 4. Okay, now we're going to introduce the fundamental counting principle. When you were doing those last examples, you should have realized that there was probably a quicker way to do that. And you could have probably got to our answers more quickly. The first answer had 8 different outcomes. The second had 12 different outcomes. So here's what the fundamental counting principle is. If one event can occur in m ways, and for each of these, a second event can occur in n ways, then the number of ways that the 2 events can occur is m times n. So the counting principle can be extended to 3 or more events. So in other words, okay, that probably didn't make a whole lot of sense to you. So I'm going to put it in a little bit easier words to understand. It's the product of the number of outcomes for each event that can be chosen individually. Okay, so basically what we're doing is counting the number of ways that each can occur and multiply them together. So let's use that strategy to figure out example number 5. It says, how many different dinner choices are there if you must choose one side, one plate, and one dessert? So we have to choose one of these, and one of these. So we need to count the different possibilities. So how many sides are there? 3. How many plates are there? 5. And how many desserts are there? 2. So what we're going to do, the fundamental accounting principle says it's the product of the number of outcomes for each event. So we're going to multiply these 3 events together. 3 times 5 is 15, and 15 times 2 equals 30. So there are 30 outcomes. Now, this is a shortcut to doing a tree diagram, because a tree diagram would have been very time consuming if we had to create 30 different outcomes. Okay, so that's why we have the fundamental counting principle, to make it easier so we don't have to do all that work. But in order for this to make sense, we need to understand tree diagrams so that this shortcut makes a whole lot more sense to us. Okay, let's go down to example number 6. And it says we need to flip a coin and roll a die. So how many sides are there on a coin? 2. And how many sides are on a die? That's correct, 6. And 2 times 6 is 12. So we have 12 different outcomes. And you can picture the tree diagram that we made where we had the 2 coins and 6 branches coming off of each coin. Okay, now example number 7 says spin the spinner and roll a die. So how many different colors are on the spinner? That's correct, 8. How many sides are on a die? That's correct, 6. And 8 times 6 is 48. So there's 48 outcomes. And go ahead and, I always like to circle my final answer. Okay, now it says roll 2 6-sided die. So we're rolling 2 6-sided die. So I need 2 blanks here. And how many sides are on a die? That's correct. There's 6. So we're going to do 6 times 6. And what's 6 times 6? 36 outcomes. Okay, and circle your final answer. Okay. Example number 9. Your class is having an election. There are 3 candidates for president. So underline. 5 for vice president. 2 for secretary. And 6 for treasurer. How many different groups of winning candidates are possible? So there are 3 for president, 5 for vice president, 2 for secretary, and 6 for treasurer. So we're going to multiply all of these together. So we have 3 times 5 is 15, times 2 is 30, and 30 times 6 is 180 outcomes. So there are 180 different outcomes for this election. Okay, turn to the final page, which is page 5. Okay, in example 10 here, we have find the missing value for each situation. So we have event 1 and event 2. So event 1 says 2 skirts and 3 tops. So how many different outcomes would there be? We can do 2 times 3, which is 6. So put in 6. Okay, the next one, 3 times 4 is 12. The next one, 3 breads, 5 fillings. So 3 times 5 is 15. And the next one, 12 flavors and 6 toppings. That multiplies together to give you 72. Now, look at the next one. This is a little bit different. Now I know the possible outcomes. I know event 1 here is 8 desserts. I want to know how many drinks there are. So 8 times what is 24? That's correct, 3. We don't know how many dresses, but we know there's 5 belts. So what times 5 is 35? That's correct, 7. Okay, we know there's 3 salads. How many sides are there if there's 27 outcomes? So 3 times what is 27? That's correct, 9. And the last one, we don't know how many meats, but there's 6 breads. So what times 6 is 42? That's correct, there are 7. Okay. Now we're going to look down below and we have 4 different word problems to solve here. So example number 11 says, a spinner has sections labeled A, B, C, D, and E. The faces of a number cube are labeled 1, 2, 3, 4, 5, and 6. What is the total number of possible outcomes of 1 spin of the arrow on the spinner and 1 roll of the number cube? So we're spinning the spinner 1 time. We're spinning, rolling the cube one time. So we need another blank. Now, how many possibilities are there on the spinner? There's 5 letters. And how many possibilities are there on the cube? There's 6. And so 5 times 6 is 30. So there are 30 different outcomes possible. Okay, looking at the next example. The digits 1, 2, 3, 4, 5 are used to make a 4-digit number. Each digit can be repeated. What is the total number of 4-digit numbers that can be made using these digits? So we're creating a 4-digit number. So how many blanks do we need? That's correct. We need 4 blanks. And how many digits are there? 5. And they said that each digit can be repeated. So we're going to do 5 times 5 times 5 times 5. Okay, 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625 outcomes. And go ahead and circle your answer. Okay, example number 13. The BMMS basketball team is ordering new uniforms. The uniforms come in 8 different colors, 4 sizes, and 5 styles. How many different outcomes of uniforms are available? So we have 8 different colors, 4 sizes, and 5 styles. 8 times 4 is 32, and 32 times 5 is 160 outcomes. Okay, and the last example here. The FFA is planning on reseeding the fields at BMMS. They are choosing between the following grasses: orchard, Timothy, and Bermuda. And 3 different fertilizers. How many different combinations are possible? So they're picking from 3 grasses here: orchard, Timothy, and Bermuda. So that's 3. And 3 different fertilizers. So we're going to do 3 times 3. And 3 times 3 is 9 different outcomes. So to recap what we did here, the fundamental counting principle multiplies the different events together. And this is a much easier way to figure out the different outcomes rather than making a tree diagram. Because making a tree diagram for 625 outcomes is going to be very time consuming. Okay, that concludes our notes on fundamental counting principle. I hope you have a great day.